Hello there, welcome to GCSE Physics. We're still talking about properties of waves. If you recall, in our last lesson we talked about refraction of light, and then in refraction of light we got to learn about some 4 important facts. In the 4 important facts we saw that 1, when light is moving from a less dense medium to a more dense one, the refracted ray bends towards the normal. When the opposite happens, the refracted ray bends away from the normal. What I mean by that is that when light moves from a denser medium to a less dense one, refracted ray bends away. In a parallel-sided block, the emergent ray is parallel to the incident ray, but it is only displayed sideways. And then the 4th fact was that when light is traveling along the normal, there is no refraction. We also talked about the refractive index, where we got to see that n is equal to sin I over sin r, or n is equal to the speed of light in air divided by the speed of light in the medium. Today we're talking about the total internal reflection. The first thing I would like us to see is that when light passes at a small angle of incidence from an optically dense medium to a less dense medium, here we can think of it as from glass to air or from water to air, there is a strong refracted ray. So here is our incident ray. It meets at this point, and then there's a strong refracted ray. And a weak ray is reflected back. So a weak ray is reflected back to the dense medium. So here two things are taking place. At a small angle, there is a strong refracted ray, and then a weak ray is reflected back into the dense medium. If you can see over here, the incident ray I is smaller than R, which means that from a denser medium to a less dense medium, I is smaller than R because the refracted ray bends away from the normal. So here what we are basically saying is that at a small angle, when light moves from a denser medium to a less dense one, there's a strong refracted ray and then a weak reflected ray back into the medium.